Module 4A, Pacific Island Evolution. As we recall from last week, plate tectonics play an important role in forming volcanoes. When these volcanoes emerge above the surface of the ocean, they form islands. This week, we are going to learn about the 5 major types of islands found in the Pacific. The islands of the Pacific have originated as linear chains of volcanic islands, either where mantle plumes have pukat at the center of plates, or at plate boundaries where volcanic arcs form as one plate is being subducted under another. Over time, high islands can also erode into atolls or become uplifted coral reef platforms. Islands may also be remnants of continental crust. We will start here by looking at continental islands. Continental islands are islands that were once connected to a continent but have since broken off by shifting tectonic plates or unsubmerged parts of the continental shelf that are entirely surrounded by water. For example, Papua was once a part of an Australian supercontinent known as Sahul, shown here in yellow. During this time, sea level was lower, and humans are believed to have entered Sahul at approximately 40,000 to 60,000 years ago. Papua Island is a part of the Australian continental plate, but became separated from Australia when sea level rose and the Torres Strait flooded around 5,000 years before present. As you can see in this image, the tectonics in this area are super complicated. Plate tectonics in the Papua region are very complex, and they played an important role in the evolution of the island. Shown in this image, there are multiple plates, each represented by a different color. If you take a look at the plate boundaries represented by the lines in this image, you will notice there are areas where plates are spreading away from each other. For example, near the Aru Trench in the west, there are also areas where plates are converging, or one plate is being subducted under another plate, represented by lines with triangles. And there are also areas of active strike slip faulting, where two plates are sliding past each other. While much of the southern portion of Papua is referred to as Australian Craton, or remnants of the Australian continental crust, shown in that beige color, the northern regions formed and are composed of various island arcs. We will discuss island arcs in further detail, but essentially, land was added to Papua as the Bismarck, Solomon, and Pacific plates collided with the Australian plate. These processes have resulted in rocks that are ultramafic and weathered to soils that are very high in elements such as magnesium, iron, nickel, cobalt, etc., making them good for mining but very poor for plants. Here are images of gold and copper mines in Papua New Guinea. Aotearoa is another example of a continental island. Approximately 85 million years ago, Zealandia, a continental mass, separated from Australia and moved into the Pacific Ocean. Much of Zealandia sunk into the sea. The North and South Islands of Aotearoa are remnants of Zealandia that have been uplifted. The Pacific Plate, which is an oceanic plate, is slowly being subducted beneath the Australian plate, which is the continental plate. This results in active volcanoes, earthquakes, and tsunamis. Next, let's transition to high volcanic islands. High volcanic islands typically form two ways: at hotspots and at convergence zones. We're going to focus here first on convergence zones. So a volcanic arc is part of an arc trench complex, which is the part of a subduction zone that is visible at the Earth's surface. As you recall from previous lectures, a convergent boundary or subduction zone is where a tectonic plate composed of relatively thin, dense oceanic lithosphere sinks into the Earth's mantle beneath a less dense overriding plate. The overriding plate may be either an oceanic plate, or a continental plate. If the overriding plate is continental crust, it will accrete or grow islands, as was the case at Papua. If the overriding plate is oceanic crust, then eventually a linear chain of volcanic arc islands will form, as shown in this image. In addition, the boundary between the subducting plate and the overriding plate typically coincides with a deep trench. This trench is created by the gravitational pull of the relatively dense subducting plate pulling the leading edge of the plate downward. Multiple earthquakes will occur within the subducting slab, and the volcanic arc forms on the overriding plate over the point where the subducting plate reaches a depth of about 120 kilometers and is a zone of volcanic activity between 50 to 200 kilometers in width. An example of a volcanic arc island system are the Marianas Islands. Here the Pacific plate was subducted beneath the Marianas plate. The Marianas Islands are a crescent-shaped archipelago comprising of the summits of 14 longitudinally oriented, mostly dormant volcanic mountains in the Northwest Pacific. The Marianas include some notable islands such as Guam, shown here in this image on the right, Saipan, Rota, and Tinian Island. Politically, the islands have ties to the U.S. and are governed separately as Guam and the Northern Marianas Islands. The next group of islands formed from a hotspot. As you recall from last class, Hawaii formed from a hotspot. As a review, we're going to watch this video called How Did the Hawaiian Islands Form? At the link shown here. So take some time, pause the video, and open it up in YouTube. Hotspot volcanism is not unique to Hawaii alone. If we take a look at this map here, we will see within a region referred to in the Western world as French Polynesia, you'll find 3 hotspot chains. The Marquesas in the north, the Tuamotus, and the Society Islands. The Society Islands include Tahiti and are about 0.06 to 4.3 million years old and are comprised of mostly high islands with beautiful large fringing reefs. The Tuamotus are much older. They're about 42 to 47 million years old and are comprised mostly of atolls and uplifted coral platforms. And the Marquesas Islands, the closest of the group to Hawaii, are about half to about 5 million years old. So first we'll take a look at Tahiti. You can see Tahiti is a high island eroded from 2 volcanoes, Tahiti Nui as well as Tahiti Iti, the smaller of the 2. The island is surrounded by a fringing reef that formed as the island eroded. And a notable feature of these islands are erosion, which can be seen as deep valleys like those shown here in this image. Mo'orea was formed by a single volcano. Mount Tohiva or Tohia is the island's highest point at about 1,200 meters. Bora Bora, another island in this archipelago, was formed by an extinct volcano. A little different from Tahiti and Mo'orea. You can see that the island is surrounded by a fringing reef and small low-lying islands, as well as a beautiful lagoon. Located north of Tahiti and Bora Bora is the high island group called Marquesas. It is believed that under current conditions, isolation, warm water, and high nutrients of this region have limited the growth of coral reefs. So this is a high island with very few coral reefs. It is also believed that in the past, as sea level was rising following the last ice age, that coral reefs could not track sea level rise and they eventually drowned. So paleo reefs can be found about 60 to 130 meters beneath the sea surface. Much of the modern shallow reefs that are present are essentially rocky reefs with low coral cover and diversity. Note here in this image of the Marquesas the steep valley walls and cliffs and the lack of coral reefs. You see a deep blue ocean. It is typical of this region. Here, the north coast of Hivaoa of the Marquesas. Again, deep water close to shore and steep mountains. The next group of islands that we're going to discuss are atolls. Atolls are the most common type of islands in the Pacific. They form over millions of years after volcanic islands have stopped growing or moved off of a hot spot, and they begin to submerge into the ocean. So here I'm going to play this video and we're going to talk through the process of island evolution in a little more detail. So an island begins as a submarine volcano. The volcano grows until it eventually emerges above the sea surface. Over time, it will continue to grow into a high island. However, as the island ages, it erodes, sinks, and subsides into the ocean. A fringing reef will form around the island, and eventually the entire old volcano will sink below the sea surface. The island is now completely composed of coral, rubble, and sand. It's an atoll. The entire process takes millions of years to occur, and we will discuss this process in more detail in our coral reef lecture. So this image here above, we've seen this before. It shows Hawaii Island. Kilauea is currently erupting, as well as Mauna Loa, fairly recent. Oahu is about 3.4 million years old, and the oldest atoll island in the Hawaiian chain in Papahanaumokuakea is about 28 million years old. From a Hawaiian perspective, we have an olelo no eau, or a traditional Hawaiian proverb, which says he puko akani aina, and it describes the process that forms atoll islands. The sand that makes up the island comes entirely from the reef. In this sense, coral reefs literally feed the islands with land. And you can see that here in this image. We dug a shallow trench within an atoll island, see a very thin soil vegetation layer, and the island itself is composed entirely of carbonate material from the reef. Here are some images that show you various atolls across the Pacific. Atafu Atoll in Tokelau, you can see here, is located on a ring-shaped reef platform with a lagoon in the center. Majuro Atoll here is the capital of the Republic of the Marshall Islands. It's an urban atoll that is densely populated. And then on the right is Palmyra Atoll, located in the Central Pacific, just about halfway between Hawaii and Samoa. It is a natural wildlife refuge managed by the U.S. Fish and Wildlife and the Nature Conservancy. This image here is a rendition of a floating island city in the Maldives. And as sea level rises and accelerates, there have been more discussion of the possibility of raising islands or building completely new islands as a possible solution. Some of the first artificial islands are being built in the Maldives in the Indian Ocean. So the final island type that we're going to discuss today are uplifted coral reef platforms. These islands are composed of old coral reefs, and the coral reefs are either raised by tectonic uplift or become exposed by a fallen sea level. So you can see here, this image of Niue Island, you can see living, thriving coral reef offshore, and as you look towards the island, you don't see that black basalt material that you typically see or expect from a volcanic island. Instead, you see fossilized coral reefs. So this island has carbonate coral reef material above the surface of the ocean, and like an atoll island, the basalt or volcanic material is under the water, but unlike an atoll island, uplift or fallen sea level have allowed these islands to be taller. So next I'm gonna play this video for you, Makatea Island in the Tuamotus. Oh, and the link is not working, so I want you guys to use the link that you see here on the screen. And what you're gonna notice when you look at Makatea Atoll is this island formed as a rimmed coral reef. Originally it was an atoll. Then Makatea was uplifted as nearby Tahiti Island grew. So as Tahiti grew, it put load onto the earth, and in order to rebound that effect, Makatea began to uplift. So Makatea Island is composed nearly entirely of limestone rock or fossilized coral reef. And when you take a look at this video, you're going to see some really amazing clips of the local geology. So we're going to end our lecture here. And as a reminder, I want you all to complete quiz 4A as soon as you take this, finish watching this lecture so it's fresh.